Okay, let's continue with the next problem, which is a Java interface problem. Okay, the Java interface can only contain method signatures and fields. All right. You're given an interface, advanced arithmetic, which contains a method signature, integer, divisor sum. Okay, let's create the interface. So, yeah, okay, let's start from interface. We will have an interface, advanced arithmetic, and we have a signature of divisor sum. Okay, that's it, I think. You need to write a class called myCalculator which implements the interface. Okay, we have a class of myCalculator implements the advanced arithmetic. And we need to overwrite the divisor sum. And we can call this public integer divisor sum. Okay. Divisor sum function just takes an integer as input and returns the sum of all its divisors. So it will return a sum of divisors, right? And let's initialize the sum divisor. Sum divisor. Let it be equal to 0. Okay. For example, divisors of 6 are 1, 2, and 3, and 6. So divisor sum should return 12. Okay. The value of n will be at most thousands. Okay. So we need to print out this part, right? Then let's do this part at first. So how can we get this part? I implemented advanced arithmetic. So we want to get this superclass of the name of the calculator. Let's write this then. My calculator. Let me print this. Let it initialize and create a new object. So we need to print out the I implement parts. So how can we get this? We can get this, I think, from my calculator dot get class dot get interfaces the first interface. There's only one interface, therefore we can continue, and get the name of the interface. Okay. After that, we need to take an input from the terminal. Therefore, we will create an scanner class object, new object, system.in. Okay, so then we need to give an integer. Let's call this n, next integer. So then we need to pass this input into the my calculators method called divisor sum. Okay, let's call this system that out prints ln, because we are going to print the sum of the divisors, right? Prints ln. Let's call calculator dot class dot the method name divisor sum. Let's copy this part and paste here and add n. Okay, let's continue with writing this method. So how can we develop an algorithm so that we can sum the divisors of the integer n? So we need a for loop for this, right? For this, I'm going to initialize an I 0, and this should be smaller than and equal to, no, not equal, smaller than n. And let the I increase if I divided by 2 and the remaining is 0, not 2, right? Wait a minute. It is n. If n is, when we divide n with I, if the remaining parts is 0, then we can add these divisors into a list maybe. Let's create a list here. List integer. We have to create an integer for this. We can maybe just sum them all, right? So when the I is divided by and n is divided by I and the remaining part is 0, then we can sum with divisor by n, not n, I actually. So what did we do here, right? For example, we have 6 here. It will start from, no, it should start from 1, right? Because we are going to start to divide by 1, 2, 3, and 6. We don't have to write 0 because the 0 will have no effect on the sum divisors, right? So we can start from 1. If we call here 6, then at first it will start from 1. 1 divided 1 Oh, 6 divided by 1 is 6 and remaining is 0. Therefore, we will add 6. Then it will continue with 2. When I is 2, 3 over divided by 3. No, 6 divided by 2 is 3. And the n, then I is 2. We can add the 2 at 6, so 8, it became 8, right? I think it should work. Let's check this out. Yes, correctly. All tests are passed. So it's a very simple question actually. Let's submit the code. Okay, all the tests are successfully passed.